Thank you for having me. Thank you to Enoforum, to Vinidea, and to OIV, and thanks to you for attending my presentation. So today I'm going to present the new technique in red fermentation, and specifically we're going to talk how this technique help to manage the cap, how it affects positively in the red cap management. So before talking about how the maturation of the skin is important, let's put down the principle in the winemaking, why the maturation is very important. So we all know that the maturation is transferring from the skin to the juice, the most valuable substance and component. So we need to know which are the elements that affect this transferring of this component to the wine. We are talking about physical process, infusion, what the commonly you call soaking, no? And then the leaching is a technical word. I don't know why there is a thumb down there. I'm so sorry. But it is there. And then we have a fermentation and maturation process, temperature, a cap management, indeed, mechanical operation, pH, ethanol content, and external addition, for example, the enzymes. Other factors that involve the transferring of the component from the skin to the wine are kind of grapes, of course, ripeness of the grapes, growing environment, and transport and health of the grapes during the receiving, during the harvest. So let's come and let's go ahead with why is cap management so hard to handle, and I would add why it's so important. Skins in red winemaking. So here you have an example of a common and very usual tank, large dimension, I would say, 80,000 gallon, with a diameter of 220 inch and a height of 480 inch. Under our studies over the years, we can affirm that with that condition, you have a cap roughly of 120 inch. 120 inch, it's pretty deep. So, and about 70 tons in weight. So let's go into the cap. That is even more interesting to know what's going on into the cap with a deep cap. So you have to measure force that are in play. So you have a natural force from the bottom to the underneath the cap, which push and lift the skin out of the liquid, out of the juice or wine. So is the CO2 produced from the yeast. All winemaker knows how is very strength the CO2 produced during the fermentation. So once this force is in play, it comes a second force. So the cap go out of the liquid, and the weight of the cap naturally create a down force, which create what we call, let's say, friendly sandwich effect. Okay, so we have 1/3 of the cap out of the liquid, 1/3 soaked in the cap, and 1/3 completely compacted, pressed, and that's why it's important to manage very well the cap. So if you leave free to go, you have a compact, very tough, and cap with a high temperature inside, problem of volatile acid, with problem that comes from bacteria. So it's very important to manage and to break up the cap, indeed. So usually we use pump over. Pump over with this kind of environment make this effect you can see from the picture. So you have the sprayer on the top, you have wine on the top, and then naturally the liquid pass through the skin, create a preferential channel. So both the temperature regulation and the extraction is very limited. You have not the entire of the cup included in this process. So you don't manage very well the temperature. You may use other kind of technique like délestage or punch down, sorry, but a punch down with this cup, it's unreal. So délestage is a nice technique, but we know we need extra space, extra times, extra labors. So let's see from another prospect, the stratification of temperature in this kind of condition. So in the blue, we have the low temperature, in the red, high temperature, and in the yellow, let's say, we have the cup. So this is a trial we have performed a few years ago. In the red line, you can see the temperature set point, so what the winemaker desire as temperature. And then we have installed two others bottom probe, and one just underneath the cup. So as you can see, actually, it's very bluish. Anyway, so the winemaker, it's let's say, tricked. He thinks to have the good temperature, the desired temperature, but instead, if you control very well the stratification of temperature, you are going to find out that the temperature underneath the cup is roughly 87 Fahrenheit. Instead, the temperature on the bottom, it's roughly, let's say, 65 Fahrenheit. So we may affirm that you have two kinds of fermentation, where on the bottom, you are in risk on fermentation stop. And probably on the top, you have a very quick fermentation and high temperature, not to mention the temperature of the cup, which is very high. So as winemaker, we need to homogenize this temperature and to have less of this stratification. And so in blue line, instead, we can see the pumping over. Pumping over, it's the only technique which can drop the temperature of the cup, of course. The cup is not a good thermic conductor, so you can't stay there to try to drop the temperature by conditioning. You won't do that. So pumping over in temperature is the only way that you can use, but ineffectively. So we just mentioned about, let's say, a large tanks. But does this problem only exist in very large tank sites or even in other sites? So the answer is there in the bottom. Not really. Trouble occurs on any tanks with disadvantageous geometry. So here two very popular tanks sites in the global market, 9,500 gallon and 6,600 gallon. You can see in these two tanks, the cap, it's a deep cap anyway. So let's talk about geometry and not specifically about volume. So there is a geometry which we can say they give an high quality red wine fermentation, and others where they need more careful management of the cap. High quality red wine tanks is that one that roughly has a height diameter, what we call HD ratio, roughly around 1, and a volume not over 4,000 gallon, with a cap that has to say roughly 10, 20 inch, no more. How many of the tanks around the wine world has this characteristic? Very few, okay? So, and this is the only way where pump over, this is the condition where pump over works properly, okay? So let's say what Parsec come up, we solve this challenge. So to manage the cap in disadvantageous geometry tanks, which are the most popular and spread around the world. Why? For a simple reason. Cellars and wineries want to optimize the capacity of fermentation and want to use as much as possible the square meter in the winery. So naturally, they are going to, essentially, they try to use the height in order to have more fermentation capability. So you go in the winery, you find low diameter and high and extended higher, okay? So that's why we introduce this new technology, a way to break the cap properly, even in disadvantaged tanks. The AirMixing is a modulated injection, is a nozzle system that sequentially combines small and modulated air jets, a synergic action that produce disrupting waves. Okay, this is very important, so we mark this. I don't know if eating is start the video or not. I'm gonna try. No. Yeah, this is a video. I don't know if the guy there. So I wanted to show you how.
Did you provide the video before?
It's just eating.
But they have to upload the. No, we cannot now.
You can't?
No, I don't think so.
No, yeah, we do.
Oh, okay, good.
Yeah, better than words is to show, no? To see how is the air mixing effect. So, nozzle on the bottom of the tank, sequential combined modulated air injection, and here's the outcome. So, this specifically tanks is a 40,000 gallon tanks. In very few seconds. So you may wonder, the air mixing is patented since 2014 internationally. And what does disrupting waves mean? So you may wonder what, with this sentence, what we want to mean. So let's be short in this. So the system of air mixing uses the resonance theory, so the vibration theories. I don't know, the most common example are the swing, the pushing the swings, or the singering for the crystal glass. So with a certain frequency, the addition of the frequency, it makes the vibration increase. So many may think, okay, but what is the difference that you have with air mixing with simple injection of air into the tanks? It's very different. So let me read the items here and then to explain a bit. So simply inject air into the tanks. It's blowing a simple injection create only a pressure on the solid material and not a disrupting waves. Furthermore, the pressure is tightly dependent on the bubble strength on the solid material. What means? So that if I inject simply air compressor in a fermenter, I need to inject a lot of bubbles, a lot of air compressed, and to have, furthermore, a very compact and thick cap to let it work. And we don't want in winemaking to have a very strong cap. So in order to work, a pressure needs a surface to offer resistance. The harder the cap, the higher the pressure the bubble requires, what I just said. Ultimately, the high bubble blown by simple injection seek a preferential pathway where the surface has less pressure. This is a very important item. So if you inject a big amount of air compressor to break the cap, naturally this air will follow and the crack internally of the cap, creating a very big block of cap. So this block is again very compact and very hot. So we don't want that. We want to smash. We want to disrupt the cap. With a simple air injection, you have not this at all this effect. So why the disrupting wave by modular injection is different? It produces a pressure applied by compressed air, which due to the pulsing, the vibration, the calculated and distinctive frequency, cause a vibration that will cause, again, disruptive waves. So it's the vibration, it's the pulsing in how, the sequence in how this is injected that create the resonance effect. Disrupting waves vibrate the liquid to create a rhythm to fully mix the entire tank with a constant skin leaching and a proper extraction. So we have all the bunch moving, vibrating, resonancing, and then we have the collapsing of the destruction of the cap. So this is how air mixing works. So air mixing is rapid, from few seconds to at most 3 minutes in very large tanks, due to the vibration and to the modulated injection. For 2 or 8 times per day, it's very flexible according to the winemaker necessity. Has a mentioned good effect. You have a total breakup of the cap and fully submerged skin into the juice. You have a very and total temperature homogenization of the liquid and the cap as well. So it's very flexible. You can apply in new or existing tank from 300 US gallon to 160,000 gallon and more. It's not only one frequency, let's say, or what we call extractive energy. The system of air mixing, thanks to the SIGN 5000 platform and through the study that we have made, we create 15 different levels of energy. So that suit for different necessity and different size of tank. So a small tanks probably need intensity 1, a large need 15. Not only for different count geometry, but which kind of wine you want to produce. You want to extract more color, more tannin, so you play out with that. And you play with the air mixing during the different stage of fermentation. Of course, at the beginning, the cap is very soft. During the yeast exponential growth, you will have a CO2 force very, very high, so the intensity, the extractive energy has to be higher, and then you will reduce again. SIGN 5000 platform connect the extraction level with the daily repetition, so the winemaker has the flexibility and the capability to create a fermentation recipe. So it's not a system where in any day you go and you work on the tanks, but the SIGN 5000 platform, the main core of the Parsec system, the Parsec company, give the winemaker the chance to create a recipe. So for different kind of grapes, for different kind of wine style. This is a summarization of what Parsec is. Air mixing is included in a list of function, in a large portfolio of functionality. And all these functions you see here is a recipe as well. So the SIGN 5000 platform will join all the recipe, control temperature, air mixing, MOX, Parsec density, self-nutrition, measurement like DO, redox, pH, or conductivity together in a single big recipe, and this transform a simple fermenter in a premium one. So like I would have a smart one. So another concept, and we introduce with AirMixing, I would say innovation, is a single phase liquid skin dividing. What Parsec means with this sentence. So usually when you devat the tanks, you have free run wine that goes in another tank, of course, and then you have the skin that you dig out or you make what you call the sluicing, no? So you have two different phases during the dividing. In the case of the AirMixing, you just hit the dividing bottom. You will have a specific frequency, a specific, let's say, recipe, which move the mast and the skin together, and you end up having this kind of flow. So you have a pump, you have your tanks with the fermented wine, the juicer, and a press. Simply, the AirMixing will start to homogenize very well the skin and the wine. We apply what we call a dividing valve, a right dimensioned pump, and all together, all along, it goes straight to the dejuicer and then into the press. There are some pictures where you can see a pump here in USA we use for that, and the skin on the right. The skin, it's really protected. The wine, dividing all together, the wine works like a film of protection from a mechanical action. So the wine really make safe the skin, so you have not any kind of trimming during the transportation. What we have instead with digging out and other technique. So just to summarize that, dividing with AirMixing is simply with a pump from a tank to the press. Prior, we have the dejuicer. Reduce time to complete the dividing. Actually, the dividing time is tank divided pump flow ratio. Prevent the operator from entering the tank, no need the dig out. Operate a quality dividing, I already mentioned that. So the skin transferred along with the liquid are protected from mechanical action. By the way, the seeds are left behind on the bottom of the tank, because the AirMixing make a really nice action to disconnect the seeds from the skin. So then you have on the bottom, and you can deal with that if you want to keep or to waste out. Energy saving in AirMixing. It's very quickly a comparative experimental trial we had in Laguardiense, a winery in Benevento, south of Italy, close to Naples. Here you have the two tanks in comparison. So on the left side, you have pump-over tanks, and in the right side, you have the graphic of the AirMixing tanks. Just making a long story short, beside the better temperature management, you can see on the bottom, the orange line is the open-close glycol valve, no? So how many times is more frequently on the pump over rather than with the AirMixing. We calculate we have roughly 28 hours in the pump over system, and with the AirMixing we have roughly 7 hours of open glycol valve open. So this is because AirMixing help to keep the temperature, but also to waste out the extra temperature due to the effect. The last but not least, the working red wine with air mixing. So the workforce optimization, the labor optimization. So in case of air mixing, you have not pump around, and you have a totally automatization, as we saw with the Sign 5000 platform. So the people in the winery is needed only for filling the tanks, so moving hoses back and forwards, sampling for analysis for lab during the racking, and during the cleaning of the tanks. So less people, less human error, no? But this concept is easier to show in this way. So this is a winery in Chile, where before the installation of air mixing, a lot of pump, upper, pump over with giving some sort of oxygen or aeration, two guys over there at the end of the building. So not a very, let's say, comfortable. And a lot of energy consumption, electric energy consumption there. This is what is today. Today they have air mixing, so no pump on board or around, portable pump. And the micro-oxygenation, the oxygenation is made by our system. So this is a system that the winemaker can be certain that goes automatically. You need just a guy around the winery to check, of course, all the situation, the environment in the winery. Some awards we got along the years. Thanks for the attention. Thanks to ATP Group, our distributor, and I hope I finished.